Okay, I think I will get started. Can you all hear me? If not, please send a message. I'll be going to screen share just a little bit and give a brief introduction into AIrTonomy, a big vision that we are driving here at Purdue University with a team that is very interdisciplinary and very motivated, very excited to really change the way we think about urban air mobility in the future and autonomous air vehicles to build the foundations for the smart crossways of America. I'm going to share my screen now, and I hope everybody can see it. Are we ready? Should we get started?
I can see your screen. Looks good.
Okay, great. Then let me get started. So welcome everybody. Good morning. Thank you for making the time to this webinar too. We already had our first webinar, and today we are going to build upon what we communicated last time and provide even some more updates and some new developments related to autonomy. The goal of this video, this webinar, is to make you familiar with AIrTonomy, a cyber-physical infrastructure for next-generation autonomous vehicles that R&D experts, researchers in academia, engineers in industry can use to perform R&D related to autonomous vehicles. And hopefully you will also be joining the AIrTonomy workshop that we are organizing September 10th through to 12th. Attendees can become leaders who have then access to our infrastructure components for 6 months for free. And your input is really important at this point because we want to make sure that the infrastructure really captures what you envision as being important for your own R&D activities. So see that as an opportunity, already frame the way we develop the infrastructure at this point of time. And the earlier we can grab your input, the better, so that we can, integrate it in our internal discussion, in a discussion with a variety of experts from various universities, industries, startups, and established arts companies. I'm going to just make sure that everybody here is getting accepted. I think, Lisa, if you can just accept people as they're coming in, I'm missing them, and that would be wonderful. Thank you so much. So what is AIrTonomy? The autonomy here at Purdue, and that includes not just me, but many, many really key people, and some of those are here on this call. We envision an infrastructure that will transform how we perform R&D related to autonomous vehicles. And we focus really on safe and trustworthy artificial intelligence and machine learning and deploying them in challenging, realistic environments. The infrastructure will support a variety of operation scenarios, including single vehicles, but also swarm operations in beyond visual line of sight operations, urban areas, urban canyons, forest areas, rural areas. The goal is really to also allow you to prove that the next generation of systems will work in more complex environments that you cannot address if you work on simulation setups or if you work on lab setups. As you can see on that slide, the vision is that any R&D experts in the US or even beyond can access our physical facilities that are organized within what we call the PUP, the Purdue Unmanned Aerial Proving Ground, from anywhere in the world using digital twins, having access to ground truth data, having access to onboard software toolkits, and also other data and research services that we can then design, validate, and also demonstrate your system's safety and trustworthiness and capabilities. There are a variety of application areas. For sure, the next generation of cargo and logistics, but also we talk about precision agriculture, we talk about Forestry, digital forestry. We talk about, firefighting, first responder scenarios, also public safety scenarios. Those are really critical. And I think you have more use cases in mind than we have, so please also provide those use cases as we are talking about the call for participation later. Here is a scenario why existing systems fail. So this is a classical first responder use case. You had a fire in an urban area, urban canyon. Buildings are very narrow, and you have with your ops team dispatched a fleet of drones to find injured citizens on the ground, and they already have a computer vision algorithm on board. It might detect this citizens on the ground, but when it comes to the decision, should I drop medical equipment A, B or not, the expert on the ground was distracted, and you see that here on the slide. He missed that, and then the drone goes into a loop, a holding loop, and because of signal degradation, it hits the building. That's what you see on picture number 3. That's a classical scenario of GPS signal degradation, which can be caused by urban canyons because of the material of the buildings. Can also happen if you fly around trees and other natural objects, a big issue as you're thinking about safety and trustworthiness. And another kind of issue is like, how do you bring the human in the loop if needed, even if they're autonomous? There might be scenarios where the human is needed just because of the expertise he holds here, for example, medical expertise. With AIrTonomy, we plan to transform that because we'll provide you the opportunity to make sure that this doesn't happen, because you can build an algorithm or a system and also address edge computing issues with the infrastructure we have, with what we call the Purdue Unmanned Aerial Proving Ground, which is essential in a physical sense, and then connecting that to digital cyber physical infrastructure components that will allow you to test and validate also in the cloud remotely, so that you can then deploy really safe and trustworthy AI models for autonomy. Now, let me show you this, what we call the PUP. It's actually an interesting short name, a Purdue Unmanned Aerial Proving Ground. It is organized within a triangle, as you can see here, and it is the fact that each physical component has its own merit for R&D activities and for proving and for measuring, but together will really allow very complex missions to be performed. So we have Purdue Airport. Purdue Airport here is located where you see right now the motion capture lab and the Smart Operations Center SOC. I'll talk about this just in a little. Purdue Airport is one of the busiest airports in the United States right now. And it is something that I guess would set us apart from other sites that we have access to that airport. At the airport, we have PERT, which is the largest indoor testing facility for unmanned aerial vehicles. It's equipped with motion capture system that allows you to capture the position of a vehicle at a millimeter accuracy level. And you can emulate conditions like GNS degradation scenarios that I just mentioned in the beginning because of the nature of the setup of that facility. You can also emulate urban canyons because of building. You see that here in the picture, and study various other scenarios indoor, but still realistic. In September, just before our workshop, we will be launching or unveiling our Smart Operations Center, which we believe is the most immersive tactical operations center for remote ops, for drone operations, but also the next generation urban airspace management. And if you think about precision agriculture, think about digital farming, firefighting being performed remotely. I'll talk a little bit more on that. And then in the right-hand side, you'll see that we are going to build the PUP airfield, which will allow us to operate vehicles that have a longer range. We actually own 2 mid-scale fixed wing vehicles. You can see that here. They're produced and manufactured by a drone company, Windracers, that has been partnering with us. And we have then a field where you can also then perform operations with these vehicles that fly 600 miles and longer. And think about this, they also have a payload of 220 pounds that would allow you to maybe potentially carry along smaller drones and then fly from the Purdue Airfield to what we call the Purdue Urban Canyon Lab. let me say that this airfield that we're building here is a UAV airport that will be also registered on the FAA map. Before I start talking more about the individual components, let me also say that this will be integrated with airspace because we will work closely with our partner Saab to establish what we call the Purdue XTM, the next generation of communication network infrastructure for urban airspace integration. We'll establish an active R1410 just close to the airport, and also put passive radars just at the outskirt of that triangle so that we can also detect smaller vehicles that fly at lower altitude and make sure that we can integrate them in the standard or airspace management airspace activities. In addition to that, we also going to place low altitude network stations at within that corridor, and at the same time also work on the next generation remote IDs systems to make sure we can really integrate those vehicles in the airspace and fly operations that are realistic and also allow us for testing and proving that you can actually operate safely along other vehicles and fly very densely with other vehicles or very densely in urban areas. I hope I didn't forget anything. If so, please, my team members can maybe jump in. And let me just go to the next, to each of these components now. So as I mentioned, the part, we already have demonstrated that you can perform research there that can set you apart, and you have the opportunity to use this as a lead user for free. It's large, 20,000 square feet, has a ceiling of 30 feet, and has a motion capture system, as I mentioned, with an accuracy that you do not have anywhere else at that scale. And together with the mixed reality setup, the real-time streaming that we've established, you can then also perform, research in the cloud. And we already have a first digital twin available for vehicles that we fly in there. Also, a first digital twin available for the area, so for the PERT itself. We can leverage and build upon that, and then build digital twins, meaning real-time digital representation of physical system, the vehicles, the airspace, also the human, and maybe also other things that you want to sense. Maybe it's crop, maybe it's trees, etc. Those are things we want to represent in digital twins. Doing that is quite challenging, so we also need to have the appropriate cyber infrastructure to allow for that real-time streaming. Then let me talk a little bit about the Smart Operations Center for next generation research on remote operations. It will be equipped with good walls, VR, AR augmented reality system, so that you can perform operations in a really immersive way, in an augmented way, perceiving things that you cannot perceive in outer spaces. Let me say that. I'm not talking about space, but remotely, and then also interact and make decisions. It will also be equipped with smart wearable devices, pupil eyeglasses, eye trackers. We also have wearable EEG devices and wristbands for galvanic skin response, heart rate measurements, etc., so that you can perform research on brain-computer interfaces, real-time sensing of human states, how the situation awareness, stress. And there will also be the ability to perform research on language-based interaction, speech-based interaction, where you do not need hands and mouse anymore for interacting with a drone. Or even think of the future. It's actually not so much in the future. There's already some research in the defense world where you can use brain-computer interfaces to use your thoughts to maybe make decisions that are time critical because you think right and it goes right. I should have a small video for you to show what this kind of SOC will look like. That we just actually finished this morning to give you kind of an idea that we want this to be really a groundbreaking new space. Immersive is with furniture that you can move around, equipped based on the mission you have. If you have an ops team of 2 people, if you have an ops team maybe of just 1 person, and here equipped with Meta devices and the pupil eye tracker for a position eye tracking, and then also allowing completely hands-free control using brain-computer interfaces. We hope that other partners will join, not just Windraces, as we are performing more work on the SOC for remote operations, and as more and more partners join, individuals join, we will for sure also brand it accordingly. So I hope that you join us on September 10th, where we unveil and show more about this Ops Center and actually perform the first flight remotely. Oh, I don't want to do this anymore. So let me see. If you click further. So now I'm going to talk about the PUC, the Purdue Unmanned Canyon or Urban Canyon Lab. What you see here on the left side is just the first mock-up, but this Urban Canyon Lab will be the largest outdoor lab for drone operations. We argue that also is equipped with a motion capture system, just like the PERT, that will allow you to measure at the millimeter level the position of a drone. And at the same time, some of that motion capture system that you can see here kind of mocked up being kind of fixed, we plan to have that mobile so that you can take it to other locations. The buildings that you see there are not buildings where people would be living. For example, here we envision that this would be firefighting training buildings so that you can, emulate situations of firefighting. But since this will be very closely integrated in our wildlife area, we want to make sure that it actually fits a rural urban context. Close to the park, as you saw earlier on the triangle, we will have also wildlife areas where other researchers then could perform research on digital forestry. There's also lots of land for precision agriculture, and also maybe in people interested in animals and tracking and measuring movements of animals and wildlife, wildlife areas. What did I mention? Yeah, so this canyon, so to speak, or the urban canyons will also be not just fixed. You can emulate them depending on what structures you want to have. We think of this as being a modular. And we will also have 4 and 5G at that location so that we can also then do real-time streaming and have a digital twin of that environment, and also have the potential for mixed reality environments and sensor emulation. The POP airfield, and actually I would like to say we would like to call it Earhart Airfield. We are in the process of getting the approval from the family. I can say that it's not approved yet. Will be at a location further in the south, and there we can operate, as I mentioned, a large fixed-wing vehicle that, as you see, has a dimension and a range and a payload that is beyond what you might have currently. What's also maybe interesting for you that we can equip it with a sensor stack that is customizable, and it's quite easy to swap that back and forth within a few hours. What we also will have here is 2 hangars on the right-hand side and an office. So for a research team that is planning to perform research at that location, you can also be placed there, and we'll have our ops team there. We envision that there will be research related to various application areas, but I think 4 areas could be articulated at this point. On the one hand, people that are interested in complex mission in real-world environments, BV loss, long missions, high payload, weather disturbance, firefighting. Then operations, GPS denied environments, search and rescue buildings, transition from outdoor, etc. And then people that are interested in human team and human in loop, where you have a remote pilot or other forms of end-user interaction. As I mentioned, someone working on precision agriculture. And then finally, also sensing and measuring at scale, where you have the need for sensors on board that are highly precise, and where you maybe potentially also need geometry models for digital forestry, biomass measurement, etc. This is kind of scenario how we can kind of envision this to happen. Just imagine you already have an algorithm, you have tested that or developed that with some of the data that we collected before in our PERT, and you were interested particularly in GNS signal degradation. Well, we could then stream that on board in our fleet, and we can also emulate the condition by streaming it in our common network and infrastructure. And then you could basically fly outdoors with these emulated conditions. And then at the same time, we would also deploy an ops team, and the data collected there could be used by others that are interested in maybe modeling some human or some brain-computer interfaces. And then the data would be actually streamed in real time. In our vision, this is the goal, and then would be available for you immediately. And we also have the goal to make data widely available and then also share it for others, for sure, within considering privacy and other issues. So there are multiple things you can address in the future R&D activities. People interested in human autonomy teaming, people interested in machine learning enabled path planning in GPS denied environments, perceptual multimodal path planning, and also AI machine learning assisted sensing at multiple scales. Those are all important questions. What we now need from you is your use cases. And just giving you kind of heads up, thinking ahead, we're thinking of a usage model here, trial version, hourly rate, annual rate. It might also be just project-based, weekly-based in the beginning until we have that ability to scale. Our goal in the long run is to have 100 flights a day, indoor, outdoor, and to POP airfield. For sure, those will be short flights in the POP, for example. But the goal is to really have a lot of operations so that you can collect a lot of data that you can use. This is POP, Purdue Unmanned Aerial Proving Ground, where we prove and where we measure. We wanted to move from proving and measurement to actually moving people and things. And that's why I think that we want, in the long run, or hopefully not too long in the future, we can expand from this about 15-mile corridor and move towards a really, really big corridor of 200 miles, where you can also then fly here, as you can see, to Muscatatuck, which is the largest testing facility from the Navy here in Indiana, and maybe also going via Crane, which is another testing site from the Navy, so that we do not go and fly over the big city here, Indianapolis. And then also there's another kind of corridor mapped out where we then want to move people along the railway down to Indianapolis and maybe perform missions related to medical delivery. We do have someone here in the call, I just noticed, is interested in time or organ delivery, and I think such a smart corridor would allow us to also then to fly down to Indy along that corridor with an unmanned vehicle, a drone. We're also thinking about air taxis in the future. Well, I'm now at the end of this presentation, so I tried to make it relatively succinct. But before we close, just keep in mind, we have that launch event September 10th. We're going to actually open that Smart Operations Center. You saw a really short clip right now that we mocked up this morning, and we'll perform their a mission remotely. And we will also have panel discussions with representatives from the industry, startups as well, but also companies that are really important for us here to build such a smart corridor. We have people from Saab here, leadership from Purdue, hopefully also from the FAA and NASA. And then there's will also be some keynote speeches at the dinner that's by invitation only. There will also now be a kind of call for participation. It's been published already. We ask you to fill in the use cases, write a short 300, I think, words use case for us, and then you can present your use case in a short lightning talk or with a poster and participate in breakout session. And we also invite PhDs and postdocs, junior faculties, engineers in industry to do so. The more we learn from you, the more we can actually make sure that we grab your interest. Think about the sensor stack that you want. Think about what kind of scenarios you envision, how you want to use the different sites and facilities, and certain requirements that you have. Maybe you have certain requirements with your vehicles, certain requirements in terms of also charging. That's also something that comes up all the time that we need to address and maybe haven't considered sufficiently. Yeah, that's it from my side. You can win travel grants, I forgot to mention that. And best presentation awards will also be announced at the workshop, and also the most innovative ideas. Thank you. That's it. Join us, please, and do not forget to also register. Here's the link here, but you find this all on our website. And I hope this kind of works now. We do have a website. Whoops, that's now the wrong click. I didn't want to do that. Here's our website, and you just RSVP here, and here's the call for participation, where you can then also just submit your use case here, submit your ideas, and you will have access to the form. And I think you just see there what I just said and summarized on this page described.